This is lesson 4.3, Congruent Triangles, and in order to do this lesson, I want to first give you the why. Why do we want to do this lesson? Well, our goal is to be able to prove relationships in triangles. That's what we're going to be doing in Chapter 4. But in order to do this successfully, we have to know how to correctly write the congruence relations. And that's what this lesson's all about. It's about writing the congruence relations. So I'm going to start you off with a lesson fact. This is something that needs to get in your portfolio. Two triangles are congruent if all their corresponding parts are congruent. Now, what the key concept is to understanding this lesson is that letter ordering matters. It's a big deal. All right, so now let's go over to two triangles. These two triangles are congruent, and the reason why is because all of their corresponding parts are congruent. Here is segment AB. Segment AB is congruent to segment DE. But letter ordering is important. So I cannot say that A to B corresponds to E to D. A corresponds with C. Angle A corresponds with angle C. Angle B corresponds with angle E, and angle C corresponds with angle F. So I have to make sure that I have the ordering of the letters correctly. And that's one of the key things we have to know about this lesson. You're going to be asked to write a congruence relation. And there are different ways to do this, so long as the letter ordering is correct. So notice that A corresponds with C, B corresponds with E, C corresponds with F. So one of the letters I could write is, or one of the relations I could write is triangle ABC corresponds or is congruent to triangle DEF. I could also write triangle BCA, since B corresponds to E, C corresponds to F, and A corresponds to, that should be D, so let's fix that. I'm glad I made that mistake. So let's fix that. E, F, D. That looks a lot better. So let's make sure I got everything right. B corresponds to E, good. C corresponds to F, good. And A corresponds to D, good. So triangle BCA is congruent to triangle EFD. Or I can also say triangle BAC is congruent to triangle EDF. So that's how I would write a congruence relation between the two triangles. I call this the big six. So there are 6 things you have to have in order to get two triangles congruent. And the first thing you have to have is all their angles. So there are 3 congruence relations you have to have for the angles. A congruent to D, angle B congruent to angle E, angle C congruent to angle F. But you also have to have 3 side congruences. So segment AB is congruent to segment DE. Again, letter ordering matters, so you could not say that AB is congruent to ED. AC is congruent to DF, BC is congruent to EF. Once you have those big 6, you can finally say that the two triangles are congruent. Here's another example. I've got line M and N, and I've made them parallel. And then I've created 2 transversals, Q and P, that are not parallel. However, I am going to say now that since the 2 lines are parallel, I can use those nice properties from Chapter 3, and I can actually get these 2 triangles to be congruent, but I've got to get them in the right order. So, okay, how do we do that? Well, here's what we do. We make sure that we start with the first triangle. So I notice here is B to A, and down here is C to D. But now the question is this: does B correspond with C, or does B correspond with D? Well, the alternate interior angle theorem is what gives it away. This angle here is alternate interior with this angle here, and that means that B corresponds to D. So this angle is congruent to that angle, and by alternate interiors, this angle is congruent to that angle. So B corresponds to D, A corresponds to C, E corresponds to itself. So now I know which letter corresponds to which. So now I can actually write out the congruence relation. Let me grab a piece of chalk. And I know that this angle right here is congruent to this angle right here. I know that this angle right here is congruent to this angle right here. And then by the vertical angles theorem, I know that this angle is congruent to itself. All right, now we're ready for the congruence relation. And so the correct congruence relation to write is that triangle BAE corresponds with triangle DCE. B corresponds with D, A corresponds with C, and E corresponds with itself. So again, I want to make sure that you understand letter ordering is a big deal in this lesson. We can't just willy-nilly write any two triangles are congruent in any order that we want. Okay? So, I haven't written out all the congruents, but I'm just going to talk them out. Angle B is congruent to angle D. Angle A is congruent to angle C. Segment BE is congruent to segment DE. Segment AE is congruent to segment CE. And segment AB is congruent to segment CD. And those are all the congruent statements. All right, 4.3 is going to lead us obviously into 4.4, which talks about side, angle, side, and side, side, side. And those two, one of them is a postulate and one of them is a theorem. And those are actually shortcuts. Right now I have to have the big 6. I've got to show that all 6 are true in order to get the two triangles congruent. But the next lesson, I'm going to have a little bit of a shortcut. And so if I have 3 corresponding sides, or a side, an angle, and a side, then I'll be able to say the two triangles are congruent then. So they're kind of like shortcuts. All right. And so now here is the 4.3 guided practice. Let's go ahead and do it. Apply the vocabulary from this lesson to answer each question. An everyday meaning of corresponding is matching. How can this help you to find the corresponding parts in two triangles? Well, if it means matching, then all you want to do is find the matching parts in the two triangles. Find the parts that are congruent and the ones that match. If triangle ABC is congruent to triangle RST, what angle corresponds to angle S? Well, again, letter ordering in this lesson is absolutely important. So if these really are congruent to each other, then all you have to do is notice that S is the middle letter here. Correspond that or match that with the middle letter here. And so the angle that has to correspond to S is angle B. Given that triangle RST is congruent to triangle LMN, identify the congruent corresponding parts. The first two letters are RS, so I go to the second triangle, LM. So segment LM goes here. LN is the first and last, so the segment here is RT. So this is segment RT. Angle S is the middle letter here, so M is the middle letter here, so angle M. TS, that's the last letter and the middle letter. That corresponds to N and M, so NM goes here. Angle L is the first letter, so that corresponds to angle R. Angle R goes here. Angle N, that's the last letter here, so that corresponds to the last letter here. So this is angle T. Given that triangle FGH is congruent to JKL, find each value. I want to find out how much KL is. Well, KL corresponds, this is the middle letter and the last letter, so that corresponds to G and H. So that means that Y is equal to this segment right here, GH. But right now I don't know what GH is. I know that this angle here is 4x minus 20, and I know that the angle K here is 108, but I don't know how long this segment is right here. K to L is congruent to G to H. X, I can find X. angle K is 108 degrees. Angle G corresponds with K, and G is 4x minus 20. So that means that I'm going to set 4x minus 20 equal to 108. I solve that equation for x, and I'm going to get that x is 32. So I now know that x is 32. Now, even though I couldn't find KL directly by setting KL equal to GH, I do notice that FG, the first two letters here, correspond to JK. So 3y minus 15 is the same measure as 12, so I can set 3y minus 15 equal to 12. Well, when I do that, I'm going to get 3y minus 15 equals 12, so 3y equals 27, which means y is equal to 9. And now I know the length of KL. KL is 9. Number 11, given that E is the midpoint of AC and BD, and that AB is congruent to CD, and that AB is parallel with CD, let's prove that triangle ABE is congruent to triangle CDE. So this is the big 6 that we need to do. All right, we know that AB is parallel with CD. That's given. And by having these two lines parallel, we now have all the nice theorems from Chapter 3. Alternate interior, alternate exterior, same side interior, all those kinds of things. I can say that angle ABE is congruent to angle CDE because of the alternate interior angle theorem. Also, I can say that BAE is congruent with DCE by the alternate interior angle theorem. So 2B is the alternate interior angles theorem. AB is congruent to CD. How do I know that? It's given. E is the midpoint of AC and BD. That's also given. Well, if that's the truth, then that means if E is the midpoint, then that means that, let's say this correctly now, ED is congruent to EB, and EA is congruent to EC. That's what goes here, definition of midpoint. I now know also that angle AEB is congruent to CED. They're vertical angles. So 6F is the vertical angles theorem. But now I've shown everything. I've shown that this side is congruent to this side's congruent to this side's congruent to this side, this angle to this angle, this angle to this angle, and this angle to this angle. So now I have shown that all the corresponding parts are congruent, and so I can say that triangle ABE is congruent to triangle CDE because all corresponding parts are congruent. That's the reason that goes here. Engineering. The geodesic dome shown is a 14-story building that models Earth. Use the given information to prove that the triangles that make up the sphere are congruent. Let's look at the givens first. We know that SU is congruent to ST. We know that SR is also congruent to ST and SU. And we know that TU is congruent to TR. We know that angle UST is congruent to angle RST, and we know that angle U is congruent to angle R. So it looks like the only thing left to prove, we want to prove that angle RTS is congruent to triangle UTS. It looks like the only thing left to prove is that this angle UTS is congruent to this angle RTS. Well, they have to be equal, and the reason is the third angles theorem. Because I have this angle congruent to this one, and this angle congruent to this one, then the third angles theorem says that this one's congruent to this one. So this is congruent to that by the third angles theorem, and now all the corresponding parts are congruent, and so the two triangles are congruent. And that is the guided practice. All right, God bless you, wherever you are today.
Praise Father,